A person is walking on a straight track such that his or her position d of t in feet from the start line as a function of time t seconds is given by d of t equals t squared. So this time it's not going to be a constant velocity because as time goes on, there's more distance that's being covered. Part A is compute the average velocity from the time interval of t equal 1 second to t equal 3 seconds using the difference quotient. So here's part A, average velocity, difference quotient, distance at 3 seconds minus the distance at 1 second, divided by the difference in the times, 3 seconds minus 1 second. So that gives you 3 squared is 9, minus 1 squared is 1, over 2. That's 8 over 2, 4 feet per second. So that's the average velocity over the time interval from t equal 1 to 3 seconds. Part B says graph d of t and illustrate the average velocity with auxiliary lines on the graph. So we had the 2 points. There was the function. We did the calculation. There's auxiliary lines. And the average velocity is 8 over 2, which equals 4 feet per second. Part C, what constant velocity could the person have walked over the same time interval to arrive at the same position at the end of the time interval? So it would have been that constant average speed, which is 4 feet per second, illustrated over here on this graph. We had the function here, d of t, and then you draw in the constant slope line here, and that has a slope of 4 feet per second. And again, the difference is the 9 minus 1, which is 8, and the 3 minus 1, which is 2. So you have your constant slope of 4 feet per second. So what's happening is that in the beginning, when you're on the function t squared, you're not picking up that much distance for the change in time. But then you start speeding up because now you're gaining more and more distance per time because it's curved. Whereas if you just went on the straight line from here to here, as far as the graph, the straight line graph, 4 feet per second, you would arrive at 3.9 at the same time as if you followed the t squared graph. Of course, after that, if you kept on going 4 feet per second constant, you would be left behind the t squared distance graph as it started increasing even more.